The first technology is called the DSL, Digital Subscriber Line. This is pretty much a legacy technology, which is building on top of yet another almost legacy technology called the telephone network. So let me draw your attention to the example at the top. Yeah, where the telephone network is, starting from here, the phone set, okay, where you make a phone call. So the signal is going to travel through the phone wire to the hub on the wall. There are lots of also wires behind the wall, connect you through the central hub in the building and then out on the streets. And there are quite a few cables buried underground, especially for Taipei City. And those cables take the phone calls to the central office. And inside the telephone company, there are these switches. They're switching the phone calls. And eventually the phone call reaches a friend that you're calling to. So this is the telephone infrastructure. And it has been there since, I think, late 19th century. But starting, I think, late 20th centuries, we want to do this. Okay, generating emails from our home PC and send that to a friend somewhere else, okay, connected also to the internet. Now, to allow this phone PC, a home PC, to connect to the internet, we borrow the telephone infrastructure, particularly the cables and the wires we have in the buildings under the street, so that we could send the data somehow to the central office of the data network providers here. And the way it works is this. Let's assume we're sending an email to a friend. So that email is going to go and reach the DSL modem first. So DSL is the name of the technology. Modem here is actually modulator and demodulator. Okay, the first few letters combined. So what it does is, hey, email coming from your PC is in digital form. It's going to be converted to the analog form, so it can go on this cable here and multiplex potentially with analog phone calls coming from the phone set. So these together can travel the cables and reach the central office of the service provider. And by the way, very oftentimes the telephone service provider is also an internet service provider. Now, once they reach the central office, this big box, DSLAM, it's DSL, I think access multiplexer, okay, whatever it's called. What the functionality of this yellow box is simply, first, split the analog signals. Some of those could be analog voice for the telephone network. It will go on this way. Some of those are for the internet. It will go on the other way. And before this analog signal can go out to the edge server, DSLAM also demodulate the signal from analog back to digital so that it can travel the digital data network. You can imagine vice versa. Your friends send an email back through the edge router and reach the big yellow box, and that email gets converted to the analog form and multiplex with the phone calls together, traveling the cable, and finally reaching the household. First, go through the splitter. If it's phone call, go this way. If it's internet data, go this way. Now, at this point, the internet data is still in analog form, so modem here demodulate from analog signal to digital, and therefore you get to read your friend's response. Now, if you think a little bit more about the yellow box, what it does is essentially what the blue and the green box are doing combined. Modulating and demodulating. Multiplexing and demultiplexing. What is a little bit tricky there is so that how do we do the modulation right, and how do we do the multiplexing so that the voice and the digital data will not interfere with each other. And that is done and achieved by, by splitting the frequencies of the EM carriers. So how we are sending data or in analog or digital form is that we are modulating these signals onto the EM wave carriers. So we modulate the analog voice to this frequency band of the carriers, and upstream data to this frequency band, downstream data to this frequency band. And they are mutually exclusive, therefore they won't be interfering with each other. Okay, so phone is going through the 0 to 4K hertz frequency band, and upstream data 4K to 50K hertz, downstream data 50K hertz to 1 megahertz. So you see that the downstream data is using a wider frequency band, and so not surprising, upstream bandwidth only 1 megabits per second, and downstream we get 80 megabits per second. The last about DSL is this link here. Yeah, this is one link per household. This is very dedicated, okay, between the central office to the user.